All right, so they want us to prove that triangle ZIM, this one up here, is congruent to triangle REM. So this is not going to be a CPCTC because they just want us to prove two triangles. So the last thing is going to be something like side angle side or side 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 or something like that, right? That's going to be my final step. It's going to be one of those triangle congruency rules. So to do this, I need to find one of those things. Well, what do they give us? M, so we'll write that stuff and we'll write given. I'm not going to waste my time. So ZI and ER, these are parallel to each other. So a lot of times we write like this to mean that those are parallel to each other. ZI and ER. So what that means is each one of these right here is a transversal. So that's a transversal right there. And so is this one over here. This is a transversal right there. It's going through two parallel lines. And if a transversal goes through two parallel lines, there's a bunch of rules that we can use to prove congruency. And one of them is this angle right here and that angle are alternate interior angles. Right? Those are alternate interiors, so those are equal. So that's one thing I'm going to show. So I'll go ahead and write that out. Angle REM is congruent to angle ZIM, and that's by alternate interior angles. All right, the other thing we have is that by the same reason, that angle and that angle are congruent because they're also alternate interior. On the green transversal, they're alternate interior angles. So let's write that out. Angle ERM is congruent to angle IZM, and it's the same reason, alternate interior angles. So I have two angles, and now I really would love it if I had at least one side. Actually, now that I think about it, 1 and 2 are equal to each other already. So we know that 1 and 2 are equal to each other because they're vertical angles. I don't really need to say that. I could say that, but I already know they have to be equal to each other because the other two angles are equal and they all have to add up to 180, so that all three. So we know that these two triangles are similar because they have the same angles, but let's prove that they're congruent by showing that at least one of the sides is equal to the other, and that's what we're going to use this for. M is the midpoint of EI, which means this and this are equal. So IM, line IM, is congruent to line EM, and that's the definition of midpoint. So I have what now? I have a side, I have an angle, and I have an angle, a side, and another angle.
Should be side and angle side.
So now I can say that ZIM is congruent to REM by angle, side, angle. You actually also technically could say angle, side, I believe, because have you learned that? Because if you have two angles, you really have three.
Yeah.
So you could have said either angle, angle, or angle, side if you didn't go through and mention that 1 and 2 are vertical, which we didn't really. So technically we should say AAS for that one, or SAA. And there's your reason.